Hey Lewis, I'm just going to look at probability involving permutations and combinations. Again, it's just tying in what we've done the last week, so it's nothing too hard. I'm just going to go over the sample question on page 124. You'd probably be able to know it yourself by looking at the book, but we'll go through it anyway. Okay, so well, there's a class and it's called 6A. Doesn't really matter what it's called, but there's 2 boys and 6 girls in it, so there's 6 people altogether in that class. And the other class, 6B, there's 4 boys and 6 girls, so there's 10 altogether in that. Now they're saying, in how many ways can 4 pupils be selected? And here they say 2 students are chosen at random from each class. So there's going to be 2 students chosen from this class of 6 and 2 chosen from that class of 10. Right, so in how many different ways can 4 pupils be selected? So 4 pupils be selected, that would be 2 from this and 2 from that. Yeah, so it's the AND rule here. So first of all, we look at how many ways can the first 2 pupils be selected from this group of 6? Well, it'll be 6 choose 2. Okay, now the book does it like that, okay, which, and as we looked at already, is the same thing. Okay, so I'm going to stick to what I'm used to. And then the other 2 students are going to be chosen from 6B. So it's so it's 10. So it'll be 10 choose 2. Okay? And then we're just going to multiply the 2 of them. Now I know I'm not going to use the calculator, okay, because I know that that's 6, 7, 5. So 675 different ways. Okay, so this will help us now solve these other questions. So calculate the probability that the 4 chosen consists of 2 boys from A and 2 girls from B. Now we know probability is number of successful trials over total number of trials. Okay, so the way I'm going to look at this is, how many different ways can I get 2 boys 6A and 2 girls from 6B over the total number of ways I can choose 2 students from A and 2 students from B. Okay, so well, first of all, the total number of ways that I can choose 2 students from 6A and 2 students from 6B. I already have it here, correct? So it's 6, 7, 5. And then I'm going to look at how many different ways now I can choose 2 boys from this class. Okay? And then I'm going to look and see how many different ways I can choose 2 girls from this class. Okay, so if we look here, I'll make this a bit bigger. So how many different ways can I choose 2 boys from this class? Well, there's only 2 boys there, so it's 2 choose 2. Okay, I'm choosing 2 boys from the 2 boys there, so that's only one way. Okay, and then how many different ways can I choose 2 girls from, well, there's 6 girls there, so 6 choose 2. And that's 15 different ways. So my answer is 1 multiplied by 15, which is 15 over 6, 7, 5. Okay, which equals 145. So I have a 1 chance in 45 of choosing 2 boys from 6A and, remember it's the AND rule, 2 girls from 6B. Okay? Okay, so the next one. Find the probability that the 4 pupils are the same gender. Now I'm going to have to write this a different way. The 4 pupils are the same gender. So that means it could be 2 boys and 2 boys or it could be 2 girls and 2 girls. Okay, so either of these will work, and again it's or. It could be 2 boys and 2 boys, or 2 girls and 2 girls. But how about we get the probability of getting 2 boys and 2 boys first? Okay, so the chances of getting 2 boys up here, or I suppose the way we look at it is how many different ways can we get 2 boys? Okay, so how many different ways can we choose 2 boys from 2 boys? As we said, 2 choose 2. And with 4 boys here, we're choosing 2 from them. So it's 4 boys, choose 2. Okay, and that'll give us 90. So there's 90 different ways of choosing 2 boys and 2 boys, and there's 6, 7, 5 ways of choosing all together. Okay, so now we look at the number of different ways we can choose 2 girls and 2 girls. So how many different ways can we choose 2 girls from 4 girls? Well, it'll be 4 choose 2. And how many different ways can we choose the 2 girls from the 6 girls? So it'll be 6 choose 2. Okay, which will be 90. Sorry, actually, I'm wrong there. That's not 90. That's 6. Sorry. 6, 7, 5. Okay. This one. So 90 different ways of choosing the 2 girls and the 2 girls. And there is 6, 7, 5 different ways of choosing all together. So if we look here, we have 6 chances in 6, 7, 5 of choosing 2 boys and 2 boys. We have 90 chances out of 6, 7, 5 of choosing 2 girls and 2 girls. And it's the OR rule. So it's 90 plus 6, which is 96 over 6, 7, 5. Okay, and that can be shortened down to 32, 2, 2, 5. Okay, again, it's not too bad, Lucy. Okay, as long as you know your choose, then you should be okay. Just look at it this way: you're putting the total number of ways we can choose on the bottom, and the number of successful ways we can choose on top. Okay, so you're just mixing the combinations with the original way we used to do probability. Okay.